Today's video will be on simplifying algebraic expressions. So you've got two learning goals for today. The first is to add and subtract like terms to simplify algebraic expressions, and the second is to multiply and divide terms to simplify algebraic expressions. So just a little bit of a reminder. So remember, the symbols for multiplication and division are usually not shown in algebraic expressions. So instead of writing 3 times x times y, instead of writing it out like this, we normally just skip out the signs for multiplication and just record it like this. And instead of writing out 7xy divided by 14y using the symbol, we just kind of write it in this form to make things a bit easier. Okay, so multiplying algebraic expressions. So our commutative law, if we remember back to that video, says that the order of multiplication is actually not important, because 2 times 6 is the same as 6 times 2. You're going to get the same answer no matter what order you do your multiplication in. So because of this, we can actually use this, we can simplify our algebraic expressions by multiplying terms together. So for instance, we've got 5a multiplied by 2y here. So we can just do that. So the first thing I would do is I would rewrite this. So I'd rewrite it and I'd put our numbers up the front. So 5 times 2 times a times y. And from there we can solve it. So 5 times 2 is 10 a y. And that will be our answer there. Our second example, we've got 10x to the power of 3 multiplied by negative 3xy. Again, I'd rewrite it. I'd put like terms together and I'll put our numbers together. So we'll have 10 multiplied by negative 3, and then we can put all our pronumerals together. X to the power of 3, x times z. And then we can simplify. So 10 times negative 3 is going to be negative 30. And then we can write this. Now, x cubed times x is actually going to leave us with x to the power of 4 and z on the end. So multiplying algebraic expressions is pretty simple. The next is dividing algebraic expressions. So when we divide our algebraic expressions, we can actually cancel out our common factors. So for our first example here, we've got 7xy divided by 14y. So we've got y, which is common to both the top and the bottom there, our numerator and our denominator. And we can also divide by 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. So that leaves us with 1x as our numerator, but we don't actually write 1x, we'll just leave it as x, and our denominator, all we are left with, is 2. So that can be simplified down to x divided by 2. Our second example, we can do the same. So we've got a to the power of 4 as our numerator and a to the power of 2 as our denominator. So we can cancel some out there. So we can do 4 take 2, which will leave us with 2. We can't do anything with the b, and the 10 and the 15. So we can divide both of those by 5, because that's our highest common factor. 15 divided by 5 is 3. 10 divided by 5 is 2. So that leaves us in our top row 3ba squared over 2. So this has already been cancelled out there, sorry, just to make that clear. So that is how we can simplify that expression there. Okay, so like and unlike terms. These are really important when we are doing addition and subtraction with algebraic expressions. So like terms are any terms that have the same pronumeral and the same power. So you can see here 3x and 75x are both like terms. They've both got the same pronumeral x, and they've got the same power. Neither of them are raised to a power. Likewise, 7ba squared and 5a squared b are like terms. They both have the same pronumeral, so they both have a b and a b, and they both have an a squared and an a squared. So again, remember, it doesn't matter about the order. So even though in our first one the b becomes before our a squared, and in our second it's the opposite way around, it doesn't really matter because of our commutative law, where the order of multiplication doesn't matter because you'll still get the same answer. So obviously, if we have like terms, we must also have unlike terms. So unlike terms are any terms that do not have the same pronumerals, or they're not to the same powers. So unlike like terms, we can't collect these to form a single term, we just have to leave them as is. So for instance, 17x, 5xy divided by 15, and x squared squared are all unlike terms. So even though they've all got x, it's actually, they're still actually unlike terms. Our first is just x by itself in our first equation there. In our second one here, we've got xy, so it's being multiplied by y as well, which makes it have a different pronumeral. And in our last one here, it's x being raised to the power of 2, which is unlike the others. So all of those are unlike terms, even though they contain x. So when we add and subtract algebraic expressions, we can collect like terms and then add them or subtract them together. So for instance, in our first example here, we've got 5x plus 2x, take 4x. So all of these are like terms because they all have x, and x isn't being raised to the power of anything. So 5x plus 2x is going to give us 7x. Take 4x is going to leave us with an answer of 3x. Okay, for our second example, 4xy squared plus 10y squared x, these are like terms. Both have an x and both have a y squared. So we can do that. So 10 plus 4 will give us 14 and xy squared. Now, it doesn't really matter what order you write your pronumerals in, so it wouldn't really matter if you write y squared x. It's just kind of convention to put them in alphabetical order. Okay, for our second one, we've got 8ab squared, take 9ab, take take ab squared plus 3ba. So we're going to look for like terms. So the first one here, we have an ab squared. This is not a like term. Our 9ab is not a like term because the b isn't being raised to the power of 2. However, here we do have b being raised to the power of 2. So we're going to underline that one because it's a like term, and that's all we've got. Our second one, I'm going to do like let's do a dotted line, a wiggly line. So our second one, we've got an AB, and its like term is over here, BA. So even though it's been switched around, the B comes first in the second one, it's still a like term because they're still the same pronumeral and they're still being raised to the same power. So if I was solving this, I would then write it out, rewrite it with the like terms next to each other, just so it's a little bit clearer. So I'm going to have 8ab squared, take ab squared, take 9ab plus 3ba. Actually, that's a little bit unclear. I'll see if I can clear that. I can rewrite it out again. So I'm going to write my like terms together just so that I can have it a bit more clear. So it was 8ab squared, and the like term was the ab squared. Remember, take the sign. So this subtract sign was in front of the ab, so when we're moving it around, we're going to take it with us. Take 9ab plus 3ba. So from there, we can solve. So 8ab squared, take ab squared is going to leave us with 7ab squared. Take 9ab plus 3ba is 9 plus 3 is going to leave us with 11. No, it's not. It's going to leave us with 12ab. And that will be our final answer there. We can't do anything more because ab squared and ab are not like terms, so we'll just have to leave it as that, and that will count as a simplified expression. So hopefully this has helped a bit. Just remember, if you're collecting like terms, they have to be the same pronumerals raised to the same power. From there, you can add and subtract them together. Hopefully this video has helped you as well, and if you do have any questions, make sure you come and see me in class.